You are given set 1 PH3 and NH3, hydroxide and SH minus, CH3SO3 minus and CH3SCO3 minus. We have to compare the base strengths of the compounds. In set 1, nitrogen and phosphorus coming in the same group, and phosphorus is a larger atom. In a larger atom, the electron delocalization is greater, and the stabilization and the consequent base weakening is greater in phosphine. It makes ammonia a stronger base than phosphine. There is an alternate method of explaining this. In phosphine, the bond angle is 90 degrees. This means phosphorus uses pure p orbitals for bonding, and the lone pair is accommodated in the s orbital. S orbital is closer to the nucleus and has less energy, and the electrons in s orbital is more strongly held or better accommodated. In ammonia, the lone pair of electrons is in the sp3 hybrid orbital. There are 4 sp3 hybrid orbitals, 3 of them accommodating the bond pairs and 1 having the lone pair. And this orbital has less s character. Therefore, the stabilization is less. This makes the lone pair more available for bond formation. That is, the electron can attract a proton. Therefore, ammonia is a stronger base than PH3. In hydroxide and SH minus, oxygen sulfur belong to the same group in the periodic table. Sulfur is larger, and therefore there is greater charge dispersal or delocalization. Since SH minus is more stabilized, this makes SH minus a weaker base. Therefore, hydroxide is a stronger base than SH minus. The consequence is its conjugate water is a weaker acid than hydrogen sulfide. In the next set, we have CH3SCO3 minus and a CH3SO3 minus. Both these structures involve the p orbital of oxygen and the d orbital of sulfur or silicon involved in a pi bond. It is called the p-d pi bond. We will be able to draw resonance structures, and there is extensive charge delocalization. Therefore, both these anions are stabilized, which makes the conjugate acids strong. Sulfonic acid, methane sulfonic acid, is a strong acid. But among these two, the energy difference between the 4d orbital of silicon and the 2p orbital of oxygen is greater. The energy of 4d orbital of silicon is higher, and therefore the energy gap between these two is higher. When two orbitals of unequal energy overlap, there is less effective overlapping. This means there is a less degree of delocalization, and therefore this is less stabilized. This makes CH3SCO3 minus a stronger base than CH3SO3 minus.